Hi everyone, Sharan here. Welcome to my channel. We are going to continue with a few more statistics terms. The terms or the topics that we are going to cover today is the central limit theorem and margin of error. So first we will go through the central limit theorem. I will give you a quick explanation on the whiteboard, and we will go into the tutorial and then see how it works using Jupyter Notebook. And again I will come back and explain what's the margin of error on a whiteboard. So first, the central limit theorem. So as you see the diagrams over here, so what it says is whatever be the actual distribution of the data, so let it be 1, 2 or 3, whatever be the actual distribution, when you continue to take a number of samples from the actual data, and the mean of those samples that you take would end up on a normal distribution. It tends towards the normal distribution. So that's what the central limit theorem says. So from this actual data, like whatever the distribution it might be, when we continue to take small samples, like a larger number of samples, and take the mean of all these samples, at some point in time it will tend towards the normal distribution. So let's see this prove on an actual data and see if it is really true. Come, let's go into the tutorial. We just saw the central limit theorem. Like what happens, like how whatever the distribution of the actual data is, the more the sample that we take, the mean of those samples tend towards a normal distribution. So what we are going to do is we are going to read a data set, we are going to see what is the actual distribution, and we are going to see, we are going to check whether this theorem is true or not. So what we will do is we will import all the required libraries first. So I'm going to import pandas, numpy and visualization libraries. So let me import them. So and I'm going to read a sample data set, like which I have generated based on Excel. And so this is the sample data set. It has the ID and the weight. So weight is the column that we are going to predominantly, or we are going to use today to check how the distributions are, and to prove the central limit theorem as well. So now what we will do is we will see the plot or the histogram of this particular sample data that I have generated. So as you see here in the histogram, the values range between somewhere close to 60 to 150. And if you see the frequency of all those values, it's almost like quite similar. So it is not exactly a uniform distribution, but it is close to a uniform distribution. So like the frequency is almost similar to each other, all those values. So what we are going to do is we are going to check the central limit theorem. So in order to check the central limit theorem, what I have done is I have created a simple function here. So what happens is the function takes three values as input. One is the actual data, so we pass on the actual data, whatever the data that we see here, and we are going to pass the total number of subsets that we want to create and the size of each of those subset. So what would happen is, depending upon the number of subsets that we are going to create, we will calculate the mean of those each of those subset, and then we'll try to we will keep all of those means together, and then we will plot the histogram to see, not histogram, we will plot the distribution to see how the data is actually distributed. So that's what this function is going to do. So let me execute this so that this function is usable in our code. So now I have executed. So now we are good enough to call this particular function with all those inputs that is required. So now what I'm going to do is I'm going to use the data, so which is the one that we have created here in the top, and I'm going to pass on number of subsets as 5 and the size of each subset as 30, and I'm going to simply do a distribution plot to see how the data is distributed. So let me execute this one. So if you see here, the distribution is not exactly normal, but it's coming out like this. So what I'm going to do is I'm going to increase the number of subset from 5. Let's say I'm going to increase the number of subsets to 5. So let me execute it. Okay, so it is slightly it's changing, but not exactly. So let me increase the sample size as well. So from 30 to 50. So now it is trying to going somewhere close to a normal distribution. So let me maybe change this number of subsets to 100. So as you see here, now what's happening is it's becoming a normal distribution. So as we saw in the definition of the central limit theorem, as we increase the number of samples, the mean of those samples tend towards a normal distribution. So if you see previously, the distribution was almost uniform. So it was pretty much a flat curve. But now, by generating a lot of samples and taking the mean of those samples and then plotting this distribution, so if you see what's happening is it is tending towards a normal distribution. So by this, we are able to prove that the central limit theorem is true. So whatever be the data that you are working on, so when you try to take a lot of small samples and then calculate the mean of those samples, it will at some point in time it will tend towards a normal distribution. So that's what the central limit theorem is saying to us. So these are all some of the important concepts, like statistics concepts, that everyone should be aware of. So you might not be like using all these concepts on a day-to-day data science job, but it is really important. Like these are all the basic foundations that needs to be like that every data scientist should be aware of. And what we will do is we will maybe pick up a different example. So I have created another data set, CLT underscore data 2. So let me read and then show you the distribution of this particular data. So if you see here, this data is very different. Like it has some values in the peak. So it is like the curve would look something like this. Like it will go here, and then it comes down, and it is slightly skewed towards one side. So this is another data set. So now what we are going to do is we are going to use the same function that we have created. So we are going to create like 5 subset, each subset of size 30, and the mean of those subset we are going to use to plot the distribution. So when I execute this, so this is not an error. This is kind of a warning message. It says that the dist plot that we are using here, it's kind of depreciated. So, but it is fine for now. We can still use it, and it is still working fine. So maybe in the future it might not work. So maybe in the future we can change, and then we can look for a replacement. But for now, I'm good enough to go with this one. So if you see here, similarly, it's not exactly like it's kind of the distribution is kind of looks like coming towards a normal distribution. So maybe let me increase this to 500, and then maybe increase the number of samples to 300 in each of those subset. So this might take some time because like we are working on a lot of data. So let me increase it further. So as we increase the number of samples, like it takes some time because it needs to go through the function, which would be a loop, in order to get all those samples and then calculate the mean of those samples. So if you see now, it is like slowly it's kind of becoming a normal distribution. So as I increase the number of samples here, so what would happen is it will tend towards a normal distribution. So maybe let me reduce the number of elements in that subset. Maybe let me use 30, and then now it will be a lot more. It will be quickly tending towards a normal distribution. So if you see here, it's almost normal distribution. So that's hence like what we are able to say is hence we are able to confirm that the central limit theorem is proved based on the actual data, like with a practical example. That's it about the central limit theorem. So now next we are going to see about the margin of error. So the margin of error, like we are not going to come back to the tutorial, but I'm going to explain what is margin of error on a whiteboard. So let's get back to the whiteboard and then see what's margin of error.